Hey, how's everyone doing today? I'm your host, Joe Fernandez, a part of the marketing team over here at Tech 30. Thank you all so much for tuning into our webinar today. We are fortunate enough to have Trevor Silence, our application engineer from Tech 30, as he will be presenting this webinar's topic of Mathcad Prime, plots, 2D, 3D, contour, and statistics. We also have Ron Zabilski, a sales rep for Tech 30. And just as a reminder that if anyone has any questions, please drop them in the chat or the question box, and we will answer these questions at the end of the webinar. And now I'm going to be passing it over to Ron, and he will give you a little background information of who Tech 30 is and what we offer.
Thank you, Joe. Just to continue with that, as we conduct this webinar, I highly encourage you to engage with us. As Joe said, you can put your questions and comments in the sidebar on the GoToWebinar panel. Even if you have questions or comments that don't relate to the specific topic today, feel free to ask them and we can address them in our follow-up email or future webinars. And please view Tech 30 as a conduit to get feedback from PTC Mathcad product managers and the development team. As most of you are aware, Mathcad is more of a niche product within the PTC's portfolio. So we want to build a community, get the features that most fit your requirements, and get the requests so they'll be prioritized more for future Mathcad releases. So please use this platform as an opportunity to influence the direction of the product development roadmap. We'll also be happy to receive your comments or questions by email at any time after the webinar. Next. So as Joe said, I'm Ron Zabilski. I'm a solutions consultant with Tech 30. First, Tech 30 is a value-added reseller of PTC software products. Second, Tech 30 is an engineering services company that helps engineering companies do engineering. We do this with the tools from PTC and other OEMs to help our customers make the most of those tools through training and engineering services. We strive to get you and you know your business. We are at our best when we can actually expand the business of our customers and build a community by connecting them with those who benefit from networking with each other. Next. Tech 30 was established back in 2002. We currently have over 80 employees with more than 50 engineers. Our headquarters are in Mission Viejo, California, but we're distributed around the United States, meeting the needs of our customers. I'm located in the Boston, Massachusetts area. Tech 30 has small business status in 4 business units. First is our PTC software business unit. We also have a unit for 3D printing and additive manufacturing, the third for engineering services and training, and we also do some Siemens software. We can provide a wide range of engineering services, including mechanical and electrical design, static, dynamic, and kinematic analysis, design for manufacturing, assembly, and 3D additive manufacturing. We can do new PLM implementations, system integrations, and migrations, as well as training services for all those above. Tech 30 can provide services in areas of engineering and design where you currently don't have the expertise, or we can supplement your existing in-house capabilities. Next. As a PTC value-added reseller, we focus on Mathcad, Creo for CAD, Windchill for PLM, Vuforia Studio and Chalk for augmented reality, and ThingWorx for Internet of Things. Next. We also have a broad range of 3D printers from companies that we represent. You can quickly take a look at the technologies we have on this page. I'm not going to go into much detail, but just keep in mind we focus on industrial uses for 3D printing, both in plastics and metals. We help our customers make additive manufacturing become part of their finished product or to use it for tooling, fixtures, and jigs. If you have any interest in these areas, please contact me afterwards and we can have a conversation about your use cases. Next. So today's webinar is about Mathcad, is the main reason why you're all here today. Before I pass the presentation over to Trevor, I want to inform you of the services that Tech 30 provides around Mathcad. We not only sell the software, but we provide are unique value-added services to ensure the customers make the most of their software purchase. But first, what's the main value of Mathcad as a software? Well, we see them as being automation or reuse of the calculations, collaboration, sharing those calculations and worksheets in easily understood documents, the natural math capability, creating calculations as you would on paper so that everyone can understand, and you don't have to have any coding or development experience necessary. Next. One of the unique services that Tech30 offers is our conversion services for Mathcad. Customers often see the value of standardizing on a tool such as Mathcad to make it more collaborative and efficient within your organization. Some of this will become more apparent as you see Trevor's presentation. However, one of the barriers that we find is in adopting Mathcad is getting your calculations from other formats into Mathcad. We're all busy with our primary job function, so who has time to bring legacy files in from Excel, hand calculations, MATLAB files, or even Mathcad 15 files into the Mathcad Prime? That's where Tech30 can come in. If you give us your calculations in whatever format they're in, we'll convert the data for you and hand them back in new Mathcad type files. We'll even train your users to use Mathcad to ensure maximum use of the tool. So if this situation describes your state of engineering calculations, please let us help you. Next. So with that, I'm turning the webinar over to Trevor to show you the different methods of creating plots in Mathcad. It's all yours, Trevor.
Thanks, Ron. So today we're going to be talking about plotting data in Mathcad. There's a few different ways to do this. We could use 2D plots, we could have 3D plots, and also use chart components, which are a new thing added in Mathcad, which allow you to do professional looking plots, and you also have a really great control of the display of plots. Some use cases for these technologies within Mathcad is you may want to visualize 2D data. So with that, we can do multiple traces per chart. We can also customize the way they look on our plots, and you can include units in these. They also have built-in capability for statistic analysis, and with chart components, you can get graphs that are very nice looking. Also, visualizing 3D data is something that's easy to do in Mathcad. You can also use multiple matrices or functions per graph, and you can customize the plots similarly to how you would for the 2D. And you can also include units for 3D plots. So without further ado, I'm just going to hop right into Mathcad and show you a little bit about plotting. Our first example is going to be just a basic XY Cartesian plot. I have these functions defined. I have a sine of x over x, and then I have this range variable xx where it goes from 0.1 to 2 pi. And so to add a plot, we'll go to this plot tab up here, and we'll just insert a plot. Make sure that we select somewhere on the worksheet, and then we'll add this XY plot in here. So the first thing I want to do is I'll add p of x here, which is just our function. And then I'm going to add another trace. So I did that by hitting Shift and Enter, but you can always add a trace by clicking this button up here in the ribbon. And for the second trace, I'm going to do half 0.5 times p of xx. And so you can actually use two different x variables for these plots. So for the first one, we're just going to use x. And for the second one, we're going to use the xx defined. And as you can see, we didn't even define the variable x, but Mathcad is intuitive enough to know that you would like to plot this function p of x with relation to x. And so it just picks values -10 to 10 as your x value. And we can actually go in here, and by selecting on one of these functions, we can change the thickness of our trace. We can even change the style. So I could have a dash style here and make it a little bit thicker, and even change the color to like another color here, purple or red or something, depending on what you want. And it helps you kind of visualize the different data. So we did explicitly define xx to go from 0 to like 2 pi. So this is good if you need to just plot a specific range, but if you don't really care about the range too much, you just want to see the behavior of the function, you don't actually need to define a X variable for your plots. Another thing I like to show within the plots is you can actually add line markers. So I can add a horizontal marker here, and I can drag this to some point. Maybe I'd like to know approximately what this value is at the minimum. And so it'll tell you the value is negative 0.222, and then you'll have this marker here lining up that to your plot. I'll move on to polar plots now. And so polar plots are nice because you can use these to visualize some complex numbers. In this case, I'm not doing complex numbers, but we'll definitely show you how to get one of these polar plots set up and working. So our function is defined as sine A over B times theta. And so I'm just going to put R theta here. And so if you're not familiar with how to add these variables, you can always go into the symbols here in the Math tab. And we have all these Greek characters. There's some short keys too. If you hover over it, you can see if you press W and then Control G after that, it'll automatically fill in that omega. So I'll be using the short key here for theta, which is Q and Control G. And here you go. We see our whole polar plot here of sine 5 over 6 times theta, and these are our theta values from 0 to 12 pi. If I did only do up to pi here instead of 12 pi, then I'd only get one of these loops. So in order to see the full behavior of this function, R of theta, then I would have to do about 6 times of a circle, and that gives you this whole chart. And you can actually change these values live too. So I can change this to 7 and the graph will automatically update. So it's very, very quick and easy to use these kind of plots. All right, moving on. We have a shear graph. This will use some units in our plot. So I'm just going to use the basic XY plot we talked about previously. But in this case, I'm going to type shear here. And then our units is just going to be the kip. And then for our x-axis, I'm going to type position with the units feet. And there we have our shear graph. I'm going to make this a little bit thicker like we did previously. And also another cool thing in Mathcad plots is you can drag these titles around. So if I want it to be on the axis here, I can just grab it and drag it into any of these spots. And then we have our chart there with our axis titles where we want them. So this is nice to know if you want to change the way it looks a little bit or just change the orientation of your graph for other people to have an easier time reading it. Next, we're going to talk about column plots, which are a kind of statistic plot. So to access column plots, you actually need to use an XY plot first, and then you'll need to change the type into a column trace. From here, I'm just going to put our y-axis as h underscore y, and then our x-axis h underscore x. And you can see we have this column plot made right here. And so what this is actually talking about is it's an oxide growth problem on a silicon wafer. And we have 168 data points here. And so this is showing us the distribution of those data points with the growth thickness. We actually did some calculations here to get the normal curve with respect to the standard deviation and the mean. So to do that, to add that in here, I can do Shift Enter again. And I'm actually just going to add this norm here. And as you can see, it didn't really show anything up. So let's make this a little bit thicker. I'm going to make a red color. And you see it's on the bottom there, but what this actually is it's out of a percentage. So I'm going to add a unit here of 1,000, which is going to be a quick way to divide that h underscore y by 1,000. And then now you can see we have our normal plot right on top of that distribution we have previously. So this is a good way to compare your existing data set with the normal distribution of the data. You can also even drag this y-axis if you would like to have your different axes values separated on the horizontal instead of the vertical. So there's a lot of customization available within the plot itself and also how you're setting up the data. Our next statistic plot is going to be a box plot. And this is also oxide growth on silicon wafer, but we're looking at 4 different furnaces, and we're trying to get a sense of what values they usually fall under. So likewise, I'll add an XY plot here, and then I'll have to change the type again to box trace. And if you notice, there's a lot of different types in here. We have the column trace. A bar trace is really similar to column, except it's on the horizontal. There's also waterfall trace, which we'll talk about next. And there's some other traces here, which we won't go into today. As far as the box plot is concerned, it's pretty easy to add this as well. You just have to type B_F, and then to add the transpose T, I hold Control, Shift, and T at the same time, and it adds that in there. If you need to add it, you can always go back into operators here, and then add it in down at the bottom where the vector matrix operators are. For our x-axis, I'm going to type furnace, which was defined up here as F1, F2, F3, F4. And then from there, we have our box plot. Pretty simple. I'll go back into this plots tab, and then I'm going to change the thickness a little bit. I'm also going to change this color to a dark red. And you may notice that we have these two dots here, this top dot and this bottom dot. And that's because we have these two extra values in our B_F matrix. So these values aren't present in any of the samples, so they're put here as kind of extra samples. You can definitely see where the mean is for each of these furnaces, and also the standard deviation, and then the range of all the values. So real quick, easy way to do some quick and simple statistical plots here. Moving on, we're going to look into waterfall plots. If you're not familiar with a waterfall plot, it's a way of plotting multiple different lines and functions with just using one x and y variable. So I can add an XY plot here again, and then I'll change the type to waterfall trace. And for the y-axis, we're going to have YO, and then the x-axis is XO. And as you can see, it's populated this matrix here, and you can see we have a bunch of different lines, and this is based off of this calculation we have set up here. And so we compacted all these calculations into one matrix for y's and one matrix for x, and then they pick the x and y vectors that are corresponding to each other and then plot them on this graph. Just like all the other graphs, we could change our trace color and thickness. We can even add some symbols here if we want to see each point. And we could also hide the line styles. So there's a lot of different customization available within your plots. Once we get into chart components a little bit later, you'll see that there's even more customization in there. Our last 2D plot, which is still kind of a 3D plot, is a contour plots. So this will actually take a 3D function, and it'll plot it in an X and Y plot, but it will show the Z axis or the Z values in a color. So to add that, I can just add a contour plot here. And I only need to add the Z function here, which is Z1. And then we have a quick contour plot. From here, we can do a lot of different stuff. So we can actually change the axis. And this functionality is also available in all the other plots, whether it's 2D or 3D, you can change these axes. So let's just have the whole thing be a box of 5. And then this one also be -5. And so we've kind of zoomed in on the center right here. So you're able to change the axis just by clicking on it and typing it in. You can also change this heat map. So say I would like to go the max, the red color would be 300. I can just change it right here and it will update your graph accordingly. I can go back down to like 250 or 200 or something, and then it'll update accordingly. You can actually even show the values themselves right on the contour by clicking contour values. So real quick, easy way to get a visualization of the values without actually plotting a 3D plot. I'm gonna hop back into our PowerPoint. And so we went over some 2D options. We went over some of these chart types. And we also talked about markers. Another thing we didn't talk about is you can do logarithmic scaling. So if you do have a log function or some kind of data that behaves exponentially, you can use this logarithmic scaling to get a different view. If you do move your axis around, so for example, I can grab this axis and move it here I can move this one. If you move these around, you can always reset them by clicking on this cross axis at 0.0. So there's a lot of different things you can do to customize these plots. Within 3D, there's an extra feature. You can add a surface fill here. So you do have these line styles and symbol customization, as well as the trace colors and trace thickness. But in 3D, you can even do another option, which is a surface fill, and that fills in the lines with like a surface color. So it can just help you separate which kind of plot you're actually looking at. So let's get into some 3D plots right now. So I have this function defined as s of x, y, where x squared minus y squared. And so to add a 3D plot, I just go back into our Insert Plot tab and click on 3D plot. And then to add this in, I just type in s. I don't even need to type in x or y. And then we have our 3D plot right here. So like I said before, you can change the axis. It's a little different. You're not actually able to click on the axis here. You'll have to use the top right corner axis selector. From there, I can change this to something else like 150, and it'll adjust your view as well. You can change your x-axis, y-axis, and then you can also change your trace color if you'd like to. There's also this option perspective where you can apply a perspective to it, and it just changes it a little bit based on how you'd like to view it. I usually leave it on, but it's totally up to you guys what you'd like to do. And another thing we didn't talk about yet is this plot background. So by default, it's on this paper color, but you can do a transparent background where it just looks like it's on graph paper once you click out of the plot. Or we could do a white background, which is a little bit different than our paper color, but I'll just leave it at the default of the paper color. For the next 3D plotting example, we're plotting a matrix. So this is a matrix where there's x and y as the rows and columns, and then our z value is actually the value within that position in the matrix. So to add this in here, I'll type in m, and then we just have our matrix like this. Pretty quick and easy to do in Mathcad. This doesn't really look like a matrix because it's all lines, so I'm going to go in and I'm going to change the symbol to a circle. You can see they're also limited on the symbol and line styles in 3D plots. You only have one option, and you can pick both, or you can pick just one. There's no way to have none on both the symbol and line style. Also, something to notice is your trace thickness will change the size of your symbol. So this is also true in any of the 2D plots. And then as we go on, we'll be able to see surface fill in this next example. But one thing I'd like to show in this one is you can actually rotate your plot to see where the points are, and you can use this to drag it around. You can even select where you'd like to zoom into as well, and then we do have a reset view. So there is some possibility of changing the way it looks within your document, and then when you send it to people, it'll maintain that orientation that you've defined. For our last 3D plotting example, we're going to be plotting two functions and a matrix. So we'll get to see how you can have multiple traces on a Mathcad plot. So our first function is Z1, which if you remember, we used it for our contour plot. Our second function is the Z2 function, which we have defined previously up here. It's the hyperbolic sine of x minus hyperbolic sine of y. And then our last data set is our Z matrix. And this is just a subset of our Z1 function, where we're picking out 11 points. And it looks kind of jumbled right now, and that's because they're all the same color. But if we're to change one of these to a blue and another one to an orange, you can kind of see the behavior a little bit better. Also, by default, this matrix was plotted as a line, so I'll change it to a symbol, and I'll take that line style off. I'm also going to make it a little bit thicker. And then you can see how these points fall right into that Z1 matrix, Z1 function we have plotted. Also, we'll show a little bit of surface fill. So on this Z2, this orange surface, I can add a surface fill here of maybe a blue color or a red color, and it just gives you another layer of customization on your plots in order for it to be easily visible to the next person to view it, or just for yourself when you're looking back on these calculations and the data that you're plotting here. So to go into then the next section, it's chart components. So chart components are pretty cool. You can do a lot of customization in them, way more than you could in just the 2D plots. It's a little bit different of a workflow in order to get these chart components going, which I'll show you in a second. You can also do multiple traces, and they're very good at creating professional looking graphs. So let's hop in here, and I'm just using the same function we used for our very first example, our very first 2D plot. So let's go into our Math tab, and under Chart Component, I'm just going to insert a chart component here. All right, and so you can see it's a little bit different of a setup. We have our axis here, and then there's a section for inputs. So to add an input, I can go under Chart Component and insert x-axis expression. And for chart components, you have to explicitly state what your x-axis is. There's no assumed x-axis of like -10 to 10 as in 2D plots. And then another way to add input would be to just right-click. So I can right-click and insert a y-axis, and this would be p of x. And as you can see, we have one trace here. I'm going to add a second trace, so I'm going to right-click and do x2. I'm just going to keep that as x, and then I'm going to add a second y of 0.5 times p of x. And now we have two traces. So before I get into customization here, I can actually hide these inputs. So I'm just looking at the chart. And then if you notice, if I take out this and put it at or it goes from 0.05 instead of 0.01 is your steps in the range variable, we have this break in our graph. So that's something to note when you're doing chart components, is if you don't have enough points, it's going to leave a little hole there. So you want to make sure that you have enough where the chart component is going to be a full line and you're not missing any steps there. So to customize this, I can just double click on the chart component, and then a whole separate window is going to pop up. And in here, I'll be able to do a whole bunch of customizations. So they give you some presets up in the styles up here. You can pick if you want to shade the area of the graph or if you want to put columns in. They look pretty similar because of how many points we do have. Also, you can add some grids. So I'll have these two grids here. You can even use no grids, and you can have a logarithmic style as well. As far as chart options go, I can add a chart title here. And I can do all the same things that are in the preset within these tabs here. So I can change the background to like a gray background if I want. You can definitely add borders and change the other colors. You can even use a gradient. I can add a legend here, and I can put this at the top. And the title, I can also move this to above the chart. For the y-axis, it looks like it's touching the top here, and I kind of want to move that up a little bit. So I'm going to go to setup and do a user-defined range of 1.1, and then that gives me a little bit more room on top. I'm just going to change this to 10 so our axis numbers look a little nicer. You can also change the formatting here as well. For the title itself, you can add x-axis titles, you can add y-axis, x-axis titles, and then you can even change this title. So you can do sine of x over x as my title. So there's a lot of different options here. I can, just like in 2D plots, I can even change the color of this and the style and thickness. So these are really great ways to do professional looking graphs. Much more presentable than say the 2D plots that are default in Mathcad. So as a summary, there are many different plotting and chart capabilities in Mathcad Prime 5. We can use the 2D, 3D plots for just a basic visualization. We can also use the statistic plots to get insights into how your data is distributed and compare that data with a normal distribution, as we saw with the column trace. You can adjust tracings and their coloring and thicknesses in order to make them clear for both yourself and others that will be looking at your documents. Also, we've seen chart components and how they can produce, how they have much more layers of customization and produce higher quality plots. And with all these plots and tools, they're pretty easy to set up and use if you have a function with that or data available. So with that, I'd like to take any questions you guys have. Thanks for watching.
Hey Trevor, great presentation. We have a question from Kyle Tyson. So his question is, when you added a horizontal line to the 2D plot, did you snap to the minimum value? And if so, how?
I did not snap, I just dragged it there. You could go into it, if you know what a minimum value is, you can go in and just type in here too. So if it was like 0.2, I could type it there. I'm not sure off the top of my head what the minimum value is, so I just dragged it there, and it kind of gives you an assumption. You could always check out your equation as well. Maybe you could add like a vertical marker here and then see what x you have, and then you can type that into your p of x function and get something out. There's also some functions built into Mathcad where you can get the minimum value of this function too. And from there, you could feed that value into your line marker call out.
All right, thank you, Trevor. We also have a question from Alex McNabb, and Alex's question is, why would you use a chart component over a 2D plot?
So I would use a chart component over a 2D plot if I was putting a chart into some kind of like publication, or maybe I was doing a presentation for my company. I would definitely try and use a chart component over a 2D plot. There is a lot more customization. However, it is a little bit more involved to actually get a plot out. It doesn't have an assumed x-axis there. You can't do 3D plots in charts in the chart component, so that's another thing to look for and pay attention to.
All right, thank you. And we also have another question from David Easler. And his question is, can limit variable lim be part of chart component plots?
What was that?
One more time, can limit variable parentheses lim be part of chart component plots?
I haven't actually tried that myself, so I could check that out and get back to you. We'll send an email out with an update on whether or not you can include that limit into your chart component.
All right, thank you. And he said thanks. So yeah, David, we'll get back to you on that. And we also have a question from Derek Mitchell, and his question is there any way to add units to the axis in 3D plots?
So you can't add units to axis in 3D plots. You could go in and add something like a text box and then type a unit here, maybe like feet or something, and then you could drag it over to your plot there. But there's no way to like explicitly add a unit to the axis on these 3D plots, unfortunately.
All right, and we also had another question come in from Joma, and Joma's question is, when the axis variables in 2D plots are hidden, the plot area is not reformatted. So even any comments on that?
When the axes in the 2D plots are hidden,
the plot area is not reformatted.
I'm not sure how you would actually hide the axis in a 2D plot. If you mean like a chart component, then that may be something different, but I haven't actually tried that out myself. So I could also look into this a little bit more and get back to you. That's a great question though.
All right, thank you. So it looks like we have no more questions. If you do, drop them in the question box. But until then, I just want to let everyone know PTC is currently having a huge deal through Tech 30, which is a buy two, get one free discount applying to Creo design packages and PTC Mathcad packages. If you're interested in this promotion or interested in renewing your license, please be sure to get in touch with Ron Zabilski, and he can be reached at rzabilski@tech30.com. You'll see his email in previous emails and emails coming in the forthcoming. You also see his contact in previous and follow-up emails, so don't hesitate to shoot over email if you're interested in this limited time deal. And we will also be posting this video to YouTube later today. On our YouTube channel, we have previous Mathcad, Windchill, and Crea webinars, so feel free to pass those along to your friends and colleagues, and be sure to also subscribe to our channel and follow us on Twitter and LinkedIn to get information regarding upcoming webinars, events, and other topics as well. And if you please stick around just 10 to 15 seconds after the webcast is ended and leave a comment letting us know what you would want to see for future Mathcad webinars and answer our quick survey, that would be awesome. Once again, thank you all so much for attending and have a great day.